Hello there. We're here today to talk to you about empirical Bayes estimation. Empirical Bayes estimation is the use of current data to estimate structural parameters, such as mean and variance, when there's little or no prior information available. For example, in 2001, an innovative new technology transportation hit the markets, known as the Segway. There was no prior information on Segway claims available, so insurance companies were forced to use current data to assess their claims policies.
There are three general cases when using empirical Bayes. The first case is called nonparametric. This is when the structure density and the model distribution PDF are largely unspecified. The second case is called semi-parametric, and this is when the model distribution PDF are assumed to be of parametric form, such as the Poisson and normal distribution. The third case is called fully parametric, and this is when both are of parametric form. The case is dependent on the situation as well as the judgment and knowledge of the person performing analysis. The SOA will typically define which one to use on the exams. For this session, we decided just to focus on the non-parametric form. Instead of going through all the formulas, we'll just have the technical team post the notes on the website for y'all to look at.
All right, so as Zach said, we're going to just post the notes and the formulas on the website through the technical teams, so you'll be able to access those and go over those on your own. But what we're going to be doing in our presentation today is going over two sample problems from the SOA that involve non-parametric empirical Bayes theorem. And so the first example problem is number 12, and you can see the data here. So the first thing you want to go ahead and do is find the mean claim amount for policyholder X and policyholder Y. So you can go ahead and plug that into your calculators, and you'll get that X bar is 720 and Y bar is 670. And then that gives a total mean for a claim amount of 695. And we'll reference those later as we get to it. But the next thing you want to go ahead and do is find V hat, which is the estimate of the expected value of the process variance. So the way you get that, the formula is 1 over R times N minus 1, R being the number of policyholders and the N being the number of years for which you have data. And then you multiply that by the summation from I equals 1 to R, and the summation j equals 1 to N of xij minus xi bar, square that. And then so the xij are the individual claim amounts that you see here, and the xi bars are the x bar and the y bar. So if you go ahead and plug that into your calculators, well, first to delineate, to give you an idea of what the numbers would look like, you get 1 over 2 times 4 minus 1, and then multiplied by 730 minus 720 squared plus 800 minus 720 squared. Apologies. And then you continue that, and then you also have, for the y part, you have 655 minus 670 squared plus 650 minus 670 squared, and you continue that as well. And then the total that you should get is 3,475. All right, so what we do from there is we go on and we find A hat, which is the estimate of the variance of the hypothetical means X bar and Y bar. So the formula for that is 1 over R minus 1 summation from I equals 1 to R of X bar I minus X bar squared minus the V hat divided by N, the number of years for which you have data. And if you go ahead and plug those numbers in, you would get the R is 2, so this would just go to 1. And then you have 720 minus 695 squared plus 670 minus 695 squared. And then you would subtract off the V hat, which is 3,475, and divide it by N, which is 4. And the value you should get for that is 381.25. And then the next step is to make your estimated credibility factor. And the way you do that is you go through k hat, which is v hat over a hat. And you just have the numbers right there, and 3,475 divided by 381.25, and that gives you a value of 9.1148 approximately. And then from there, you find the actual estimated credibility factor, which is n divided by n plus k hat, n being the number of years once more, and you have 4 over 4 plus the 9.1148 from above, and that should give you approximately 0.305. All right, and from there, you want to find your estimated credibility premium, which is for policyholder Y, and you get that from, let's see, Z hat times Y bar plus 1 minus Z hat times mu hat, which is the overall claim amount mean. And if you plug in your numbers there, you should get 0.305 times 670 plus 1 minus 0.305 times 695, and that gives you a value of 687.4, which is answer choice C. And
All right, so Joseph just did problem number 12. I'm going to do problem number 270, which we want to calculate the estimated variance of the hypothetical means, or in other words, A hat, which he calculated earlier. This time, though, we do have 3 policyholders instead of 2. I'm also going to break down the variance a little bit more. So we start off just like he did by finding the means for each of the policyholders. So these are all pretty simple. X bar is equal to 3, Y bar is equal to 5, and Z bar is equal to 4. And then the overall mu hat is equal to 4. So now we'll go ahead and calculate the variances for each of the policyholders. So we have V hat for X is going to be equal to 1/3 of 2 minus 3 squared plus 3 minus 3 squared plus 3 minus 3 squared plus 4 minus 3 squared, which is equal to 2/3. We're going to do the same as V hat for Y, which is 1/3 over 5 minus 5 squared plus 5 minus 5 squared plus 4 minus 5 squared plus 6 minus 5 squared, which is also equal to 2/3. And then lastly, we'll do V hat for Z, which is equal to 1/3 times 5 minus 4 squared plus 3 minus 4 squared plus 3 minus 4 squared plus, skip the 5 minus 4 squared, and that's equal to 4/3. So then the overall V hat for all 3 of the policyholders is simply the average of those. So the overall V hat is going to be 8/9. So what we're solving for is A hat, and the formula for A hat is 1 over R, which is the number of policyholders, minus 1, sum from I equal 1 to R of the X bars, which is all of the means, minus the overall X bar squared, minus V hat over N, which as Joseph said is the number of years for which you have data. So in other words, this is 1 over 3 minus 1 times 3 minus 4, which is the X bar minus the overall mu hat squared, times 5 minus 4 squared, and 4 minus 4 squared, minus the V hat, which is 8/9 over 4, which is the number of years for which we have data, which is equal to 7/9, which is approximately equal to 0.778, which is answer choice D.
Thank you for joining us today. We hope you've gained a greater understanding of empirical Bayes estimation. If you have any further questions, feel free to direct them towards Group 5.
And remember, when you ride your Segway, always wear a helmet.